To LeetCode 2, add two numbers. So in this case, what this looks like, I've already written out what the example array looks like, but this is, as simple as 342 plus 564, right? Which gives us 807. Cool. However, in terms of the way that this is coded, we'll be doing the summation in this way, in this method instead, right? Which is like 342 with 4, 6, and 5, right? And so, as you may have done in school, you go from smallest to largest. So in this case, this will be 7. This will be 0, but we carry the 1. This is 7, and because we've carried the 1, we make it 8, and this would be our result, right? However, in terms of code, we do this the opposite way, right? Or, well, we'll be doing this the opposite way because it's being stored in reverse order, right? So if we were to reverse this, this would look like 2, 4, 3, and 5, 6, and 4, right? However, because we're doing it in reverse, we're not going to start from, in this case, this would be biggest, and traditionally this would be the smallest. We're going to go from left to right, right? So in this case, we start backwards, where we have 7, we have 0, we carry the 1, we have 8. And this would return as our linked list. So hopefully I don't need to explain this too much after I've written the code, but I'll show you anyway. And if I need to come back to this little drawing board, I'll come back. So in terms of code, first we want our, we want a dummy node, right? So we're going to have a list node, which we'll call dummy, which will house a new list node, index 0, cool. And we're then going to initialize this. Oh, I see an error. We're going to initialize our list node to be current, which will equal dummy. And then we want an integer, which we'll call carryover, right? And this carryover is where, when we do the summation, our carryover will have that extra 1. So if our number equals more than 10, when we add the two integers, then our carryover will be set to 1 instead, and that's what we'll then add to our integer in our final linked list. So now that we've initialized our nodes and our carryover, now we're going to traverse both lists, right? So we're going to use a while loop that will state that list node L1, or while list node L1 does not equal null, or list node L2 does not equal null, or our carry does not equal, carry over does not equal 0, then we're going to collect our values, right? So in this case, int val1 will equal L1. So in this case, we're going to be setting our value to be either whatever L1 is or nothing, right? If it's null, we don't want to use null because null is not an index, it's not a number, it's not an indice. So indice is not a number. So we don't want to use null in our summation, we want to use 0. So in this case, L1 is going to be, as long as it does not equal null, then we'll use L1.val, right? Or if it does, or else, we use 0. If it does equal null, then we're going to use 0, right? We want to do the same for our val2. So, and we'll set this to be val2. So exactly the same thing, but we do the same we just change it to val2. And then we now want to compute our sum and our carryover, right? So in this case, we're going to have an integer. We'll declare an integer called sum, and that sum will be made up of val1 plus val2 plus carryover. And we're going to call this carryover to equal sum divided by 10. I'll space it out. It looks a bit nicer. Cool. So this is how we're working over. That's how we work out our carryover essentially, right? So if the sum is divisible by 10, then our carryover will be set to either 1 or 2 because it'll be a whole number, right? It won't be returning 1.2 or 1.5 or something silly like that. It either returns 1, 0, or 2. It only returns a whole number. And it's rounded down to the nearest whole number. So if I get a 1.9, it won't be rounded up to 2. It'll be rounded down to 1, right? Cool. So now we want to create the new node with the digit part of our sum, right? So in this case, we'll type in current.next, which will equal our new list node, right? And here, our new list node will be the remainder of sum modulo 10. So if it's divisible by 10, whatever's left, once the 10 has divided into it, that will be what's left. So if you have a 7, 10 doesn't go into 7, so modulo will be 7, right? If you have 17 or 15, let's say, the modulo 10 will go in and you'll be left with 5, right? So that's why we do this little step. And then we now want to set our current to equal our current.next. This is for moving along our nodes, right? Kind of. Because then the next step now is if L1 does not equal null, then L1 equals L1.next. If we could do the same for this one as well. So, right. So this will then be L2. And in the end, so this is our sum will have been done. Once we've run through this, our sum will be calculated. And so in the end, we can just return our dummy node, dummy.next. And provided everything is good, I didn't make any mistakes, we get awesome runtime, awesome memory, and I think a fairly understandable solution. Hopefully you understand that the way that this is being summed up is, or through each iteration, is in this fashion, right? So we start with, it'll iterate amongst number one and number 2, and then it will come across and get our 7, and then it will value 2, and or value 1 and value 2 rather will be compared or summed, and then you get our 0 and our carryover will equal 1, and then we have 3 and 4 which will equal 7, and we have our carryover which will make it 8, and then we end up with this as our dummy node, and that's what we end up returning. So hopefully that was understandable. If I left something that was a bit, not fully understandable or something like that, please let me know in the comments. And otherwise, please like and subscribe, and I'll catch you in the next one. Peace.